16 on page 255. A carpenter is building a rectangular shed. Okay. Here's a rectangular shed. Good. With a fixed perimeter. So the perimeter, they say it's 54 feet. Okay. What are the dimensions of the largest shed that can be built? And what is its area? So they're not giving, they're only, so from, okay, carpenter is building a rectangular shed with a fixed perimeter and 54 feet. What are the dimensions of the largest shed that can be built? I think that these are all connected to something, all these problems. And what is its area?
It's not
Okay, very good. So we're only given the perimeter of this shed. We're not given anything else. Okay, so length, they are telling us that it's a rectangular shed. Fine. So it's not a solid. So it's not a solid, it's just a rectangular shed then. I was thinking of a volume situation, but okay. So this is X, this is Y, and we are only given the perimeter. Okay, so we are only told that 2x plus 2y equals 54. And they want us to determine the that particular shed that has the maximum, the largest shed that can be, so the maximum area. So we want the maximum area. That's the largest shed that can be built. Okay. So in order to maximize the area, first we have to write the area. I'm on page 3. So the area equals, as we know, length times width. Well, this would be 3 variables. 1 is the function, 2 is the length, and 3 is the width. So somehow we have to make 1 disappear. From this equation, because this is given to us, we have the perimeter, which is 54 feet. After dividing both sides by 2 to make it as simple as possible, I will say this is x plus y equals 27. I will solve the equation for y, moving x to the other side. So 27 minus x, which you know I always prefer negative x plus 27, so it's in the correct descending order. And now, from this, I will replace y. And then I can say the area is indeed only a function of one variable, x. So x, parentheses, because y is negative x plus 27, I distribute negative x squared plus 27x. This is what I need to find the maximum for. Again, another quadratic equation. I was expecting something more exciting, but it's not the case. Like we did before, we have to find a prime, negative 2x plus 27. Like you already told me a minute ago or 2 minutes ago, we have to set this equal to 0. We find that 2x equals negative 27, or x equals 27 divided by 2. I claim that this gives, it was in feet, yes. This gives a maximum, but you cannot trust me. You will say, show me. And I will show you why that gives the maximum. Because the linear function, the quadratic function is linear. In other words, it has a positive, it has negative slope, it's positive and then negative. So here it's guaranteed to be positive and here it's guaranteed to be negative. So this is typical for a situation of a maximum. This will be the maximum, but I have to find it. So I will determine a of 27 divided by 2, and I get the maximum. So I'll plug it in the function, a negative 27 divided by 2, and I want to square that, and plus 27 times 27 and divide by 2. And I got 182.25, and this is of course in square feet because we're talking about area. I was hoping for something more exciting. Okay, so we will come back to more problems, but I would like to continue. Any questions for me? Any questions? Okay, so in that case, let's continue with 2.6. 2.6 deals with something called differentials, marginals and differentials. 2.6, marginals and differentials. First things first. On page 4. Okay. Does anyone remember when we write f prime of x, we can also write y prime, but we also have another notation. We used it several times. Does anyone remember the other notation? Thank you very much. Good. So keep that in mind. And now let's take a look at the following function. I have a function. This is f of x. I have a point. Here is point P. Here is the tangent to the graph at point P. So this is tangent at P to the graph of the function at P. And this is the x value. And of course, this is the f of x. And let's suppose there is an error in x. So let's suppose, just imagine the idea. Let's say we want to make disks for whatever reason. We establish a factory that creates disks. I don't know what the use is, maybe for auto industry or for other industries. Just imagine that we are producing disks. And we measure and we want the radius of the disk to all be 2 inches. That's the requirement. Our customer wants whatever number of disks and the radius is 2 inches. But somehow the machine that cuts it has an error. And let's say it makes those disks with an error of plus or minus, let's say, a tiny error of 0.1 inch. But there is a problem, right? We're not able to create or build these or manufacture these disks with exact 2 inches in a radius of 2 inches. The machine that is cutting them has an error. However, maybe the customer says it's okay. But I want you to determine for me what is the error in the area. So you have an error in the radius. How much error in the area will that create? So imagine that this function is our area. Imagine that x is our radius. This is our x. This is the 2 inches. But we have this error. Let's consider it for now just positive. I can go this way or this way, it doesn't matter. So let's say it's a positive error. I don't want to show it here. I'm going to make it very big so we understand what's happening. So this is the x plus the error, dx. So dx or delta x, delta is a Greek letter, delta x or dx is the error. Very tiny, very small here, but I will not be able to show what I'm doing. So I'm zooming in. So this is the point created by, so this is point Q, and this distance, of course, is dx, which is also delta x. Huge, but no, it's very tiny, but once again, I'm zooming in so I can explain. Up here, so Q has coordinates x plus dx, and what is the y coordinate of Q? Can anyone give us the y coordinate of Q?
So x plus dx.
Brilliant. Who said that?
I did.
Thank you. So now, this difference is the error in the area, because this is the difference created by this difference in x. This is the error created in the area. So exact error in the function, it doesn't have to be area, it can be volume, it can be anything. In function is delta y, so this piece is called delta y, and that is f of x plus dx minus f of x. This minus this is this. F of x plus dx minus f of x. Good. Perfect. However, if I extend this line and I extend this line, I create this right triangle. I'm going to remove it from there because it's easier to explain, and then I'll go back. This piece is dx. This is the tangent line. This is the tangent at P. I know that it has a slope. Slope of this line is. Can anyone give us the slope of that line? From what we learned in this course so far.